Let's move on to the convergence of blockchain and IoT. In addition to blockchain, IoT is another one of the most hyped technologies. IoT bridges the physical world with the digital world. By embedding sensor and an actuator or transducer into a physical object, this device can operate in an autonomous manner. The convergence of blockchain and IoT presents opportunities to address problems that have hindered the growth and realization of the benefits of IoT. Let's spend a few minutes walking through a brief refresher on the history of IoT. The origins of IoT are generally traced back to the work of Kevin Ashton and his team at MIT as they worked with connecting instrumented devices to the Internet. Of course, if you want to trace the roots to machine interactions, you can go back much farther, including the military in World War II and radar. And you can go back to things evolving into factory floor automation and other precursors to what we now know as the Internet of Things. The work of Ashton and his colleagues at MIT gave way to a number of connected products that made their way into the market that we recognize today as connected door locks, Nest cameras, wearable devices, connected appliances, smart lighting, and similar devices. These devices created all kinds of interest in the market that began to come together in what we know as the Internet of Things. Between about 2010 and 2012, the Internet of Things itself was given a variety of different names. Cisco launched an initiative that it called the Internet of Everything. Ericsson launched an initiative it called the Networked Society. And there's the work by Temper, who's leading a team under the W3C banner called the Semantic Web. So there have been a lot of different initiatives and a lot of different characterizations, but these all sort of coalesced around the Internet of Things. In an article in the Harvard Business Review written by Jim Heppelman, the CEO of PTC, and Michael Porter, a professor with the Harvard Business School, they chart the progression of the Internet of Things market, and that progression was as follows. First, there were products, an HVAC unit, for example, which became smart products over time. Engineers decided to do something like add a programmable controller into the HVAC unit. This allowed the unit to respond to certain conditions, but that wasn't necessarily a connected unit. In fact, these existed long before the Internet was even around. But the addition of programmable controllers made them smart products, as opposed to just products. But then with the advent of the Internet and the ability to connect these smart products over the Internet emerged a whole notion of smart connected products. This gave rise to things like the Nest thermometer for the home, wearable devices such as Fitbits, smart lights, and other devices that provide value through connectivity. Connected smart devices open a new realm of product development. This is where the product developers really changed their business models in terms of achieving consumer stickiness. They found loyalty could be created from delivering a new class of products. The product development challenge became, how do I deliver a product that will report when it's going to have a problem? How do I deliver a product that will give the user the ability to control the product from their iPhone or Android? How do I create value from this new world of connected devices? The appeal of what could be provided by plugging into the Internet of Things was pretty significant. Consumers increasingly became locked into their IoT-enabled products. Porter and Heppelman, in their Harvard Business Review article, correctly predicted that these products would evolve into product systems. The evolution into product systems was required because in the early days of smart homes, for example, early adopters were plagued with the problems of trying to get multiple non-compatible devices to work on the same network in a way that would allow the devices to communicate device to device. The smart home didn't seem too smart when you had to use one application to control your doorbell, another for the lights, and yet another for the internet-connected washer and dryer. That all has been giving way to product systems so that all of these products can connect and work together via the Alexa interface, the Apple HomeKit, Google Home, or some other interworking product system. While there is still a large product focus, the movement with product systems is to consider more holistic questions, such as, how does the home do something? How does a building or a school or a factory use a set of heterogeneous but related devices in a product system? And then the last focus is system of systems, which looks at how will a product work in the wild. For example, you may have a connected car, but that connected car might need to interact with street lighting or a parking lot or an electric recharging station. You face the challenge of having disparate systems that need to interact with one another in what would be characterized as a system of systems. You can see how we're evolving from IoT as silos associated with specific products to the notion of systems where there are many different devices working together to the point where you're effectively leveraging all of the smart connected products on a holistic system of systems basis. This is a very important distinction because how you get to that point is going to be fundamentally different than just the focus of utilizing a bunch of different IoT-enabled products. There's quite a proliferation in the number of connected devices coming online every day. According to Gartner, there are roughly 8 billion connected devices today, with 5 million new devices connecting each day. This presents a possible future with 30 billion devices by 2021 and 75 billion devices by 2025. A world with 50 billion devices means that there is an equivalent number of connections between 50 billion devices as there are grains of sand on Earth. This explosive growth poses a few common challenges for the future of IoT. First, security. How do we secure all these devices and the interactions amongst them? Then, scalability. Is the current IoT infrastructure adequate to handle this growth? Finally, governance. How do we best govern autonomous devices and machine-to-machine commerce? Next, we will explore how blockchain can provide answers to these questions. If you look at connected devices today, most of the deployments are centered around the capital equipment as closed-loop message response silos. And in these silos, the data is mostly controlled by the vendors that were deploying the devices. For example, devices are established and the sensors in the devices would be capturing data, and those data would ultimately go into the cloud-based central repository of, for example, a lighting vendor or of the appliance vendor or whatever the device was. And there would be a rules engine or a workflow engine that would interpret the data coming in. At its most pedestrian level, this would be grabbing information to determine, is the device overheating? Was a door left open? What is the vibration rate? And other operational metrics. Within the closed-loop message response system were the rules of the workflow engine that was interpreting the data and sending a response. The response might be triggering an alarm, altering a process input, or whatever reaction the rules engine defined. And that's a look at the early IoT devices. There's nothing wrong with them. They yielded great value. However, the closed-loop and siloed designs led to limitations in regards to implementation. There are 450-plus IoT platform vendors in 2017. The IoT platform market is exploding at a compound annual growth rate, CAGR, of 39% and is expected to surpass $22 billion by 2023. First of all, let's understand what an IoT platform is. IoT platforms are the support software that connects everything in an IoT system. An IoT platform facilitates communication, data flow, device management, and the functionality of applications. The IoT platform plays an important part of the IoT ecosystem. It enables businesses to invest time and money in things they are good at, building applications and serving customers in the market segments they are familiar, instead of reinventing the wheels of building software services. Using the IoT platform, they can get up and running quickly and more cost-effectively. The leading IoT platforms are AWS IoT, Microsoft Azure IoT, Cisco Jasper, Huawei, PTC ThingWorx, Verizon, Bosch, Hitachi, GE Predicts, and Google. In such a competitive market of IoT platforms, each IoT platform provider has its own unique competitive advantages, such as size, industry expertise, and customer relationship. Regardless of their uniqueness, the IoT platforms have the following common features. The first is device management. An IoT platform should allow the end users to remotely provision, configure, monitor, diagnose, and control IoT devices. It should also provide over-the-air firmware updates to IoT devices. In general, IoT platforms provide a dashboard with current and historical data usage and health status data of IoT devices. They also enable end users to alter rules in automated actions to control IoT devices. Next, IoT platforms should enable bidirectional communications through mobile networks, activate devices, network configuration, diagnosis, and reset. The system usually includes a wireless module or gateway and SIM. Security has been a hot topic of IoT industry for a while. A system of IoT devices increase the security risks significantly. Detailed security risks will be described in a later section. An IoT platform should ensure the end-to-end security of the IoT systems and authenticate the devices to make sure they are the right devices and follow the security protocols. User authentication, access, and control is another important factor of IoT platforms. Where IoT systems add the most value to end users is in their capability of collecting and analyzing data collected by the IoT devices and sensors. Lots of applications can be built using the data to solve the real-world problems for end users. After the raw data is collected or the analytics are done, the IoT platform usually interfaces with a web service or other IoT device to share the data or analytical results. IoT Analytics conducted research on 16,000 public-known enterprise IoT projects. These projects don't include the consumer IoT projects, such as smart home and wearables. Consumer IoT projects are proven to be a smaller market compared with the enterprise IoT projects. And here, we focus on the enterprise IoT projects. Among the 16,000 public-known enterprise IoT projects, most of the IoT projects we identified are in smart city, followed by industrial settings and connected building IoT projects. The research also breaks down the projects by their regions. The Americas make up most of these projects, followed by Europe and Asia. There are large differences when looking at individual IoT segments and regions. The majority of smart city projects are located in Europe, while the Americas, particularly North America, are strong in connected health and connected car projects. The Asia-Pacific region is particularly strong in the area of smart agriculture projects. Most IoT projects in 2018 happened in the Smart Cities segment. We will dive into the top 4 segments. According to the research by IoT Analytics, in 2018, Smart City is now the largest IoT segment in terms of the number of IoT projects identified, 23%, while Connected Industry used to be the largest IoT segment in 2016. The growth has been driven by hundreds of recent smart city initiatives started by governments and municipalities around the world. The most popular smart city application is smart traffic, including projects such as parking systems, traffic monitoring and control, bike sharing, smart bus lanes, and other more exotic applications such as smart ferry systems or smart bus shelters. Other smart city initiatives evolve around utilities, lighting, environmental monitoring, and public safety. Europe is leading the smart cities movement globally. In the past 3 years, smart cities have become a hot topic in the U.S. As we said earlier, Europe is leading the smart cities development. The U.S. has seen an increasing demand of smarter cities from its citizens. The majority of the smart city companies in the U.S. are startups or traditional traffic agencies who have started to digitize their solutions. Verizon is one of the very free large enterprise invested in the smart cities domain. The areas we see lots of interest in development are lighting, parking, traffic, video surveillance, and citizen engagement. All of these overlap and are constantly moving targets depending on where you are and what's going on. But the right infrastructure can give you the means to meet them head-on and help you create a community that is safer and more livable, sustainable, and resilient. According to IoT Analytics, in 2018, 17% of all identified IoT projects are related to connected industry. We also call it industrial IoT, or IIoT. This segment covers a wide range of connected things, both inside and outside the factory. The most popular connected industry applications in 2018 were equipment monitoring and non-factory environments. Typical non-factory projects include asset monitoring and remote control of connected machineries such as cranes, forklifts, drills, or even entire mines and oil fields. These assets are usually expensive and mission-critical. Smart factory automation and control projects were the second most popular application in connected industry. Various smart factory projects have been implemented. For example, production floor monitoring, wearables on the shop floor, remote PLC control, or automated quality control systems, condition-based monitoring, and performance analytics of industrial machines. The Americas lead the way for connected industry projects. According to IoT analytics, of all segments, connected building has experienced the largest increase of IoT projects compared to the 2016 study, with a 7 percentage point increase. This is attributed to the real estate booming and new infrastructure development. 61% of connected building projects identified involved facility automation to reduce energy costs. 39% of projects are related to building security and 31% to HVAC, heating and cooling. Building security has been a much anticipated solution for some time. The industry is pushing towards smart analytics, smart cameras, and ease of use. There is no doubt connected cars have been the most discussed IoT application by consumers recently, with the associated value of vehicle diagnostics, driving safety, along with the vision of self-driving car initiatives led by Google, Uber, and NVIDIA. The IoT connected car projects have more than doubled since 2016, according to IoT analytics. Most connected cars, with projects in 2018, focus on vehicle diagnostics and fleet management. Verizon launched a consumer project called Verizon Connect, which enables vehicle diagnostics, real-time tracking, and alerts. In some pilot cities, Mercedes-Benz has integrated real-time traffic signals to their cars to show drivers the countdown of red, yellow, green lights. Some cities have started the pilot use of IoT devices installed in the infrastructure to study and monitor autonomous vehicles to ensure traffic safety and understand the traffic pattern impacted by autonomous vehicles. According to CRN research, 46% of IoT executives say that their IoT systems can handle up to 1,000 devices, while another 28% can only accommodate fewer than 100. Scaling IoT solutions remains a challenge today because the new IoT solutions need to work with legacy devices and the responsible departments of IT, networking equipment, and analytics. In many cases, custom and specialized solutions are required for customers to take full advantage of available IoT solutions. There will be 30 billion IoT devices in 3 years, so IoT companies need to figure out a way to quickly design and deploy IoT solutions that interface with the legacy products. Meanwhile, 30 billion IoT devices will introduce challenges of power efficiency because the total energy consumptions of IoT devices will increase. New design is required to enhance the power efficiency of IoT devices. Security is one of the biggest concerns for IoT experts and consumers. Any device connected to the internet has the potential to be hacked. Mirai is a popular form of malware among hackers, offering the ability to turn systems into botnets to initiate network compromises. In September 2016, hackers used 152,000 consumer IoT devices to initiate a distributed denial of service or DDoS attack on French hosting provider OVH. They were able to inundate the company with 1 terabyte per second's worth of traffic, causing mayhem for customers around the world. Efficiency and user experience are a good goal for any product, including IoT devices, but the ease of use, for example, like hard-coding default passwords, have been used by hackers to initiate attacks. According to Paul Mekavat, Senior Cyber Threat Intelligence Manager for the UK and Ireland tech giant Fujitsu, when an architect pulled together the design of smart motorway notice boards, they wouldn't have considered that hacktivists would target them to display politically motivated messages. The same is true of IoT manufacturers who built the hundreds of thousands of CCTV cameras, DVRs, and SOHO routers that now make up the IoT Mirai botnet. The purpose of the low-powered protocols like Zigbee, Bluetooth, Z-Wave, and 6LoWPAN is to keep the sensor working without changing the battery or power source frequently. So if an attacker is able to keep sending a wake-up signal, then eventually the sensor will run out of battery. Another possible attack method is against the exchange of keys. However, there is no silver bullet to prevent security breach. IoT experts are following the best practices to enhance the IoT security. Zigbee, Bluetooth, Z-Wave, 6LoWPAN are the common IoT communication protocols. Some IoT devices don't need real-time data collections. However, for mission-critical applications, IoT devices will require real-time connectivity and high bandwidth. At the moment, IoT is still in its infancy, and once it reaches the demand in 3 years, we should expect significant bottlenecks in IoT connectivity, efficiency, and performance. Lots of products in the market today are trying to add an IoT flavor, but not all the IoT products can justify their values. Some of the IoT products introduced radical changes. Some are enhancement of customer experience. Customers need to see and appreciate the values IoT creates in order to justify the increase of prices. For example, a water heater tank with Wi-Fi connectivity is 20 to 25% more expensive than ones without the connectivity features. Can the convenience justify the price increase? It has to be validated by the customers. The value versus price debates ultimately impact the adoption speed of that product. On the other hand, some IoT devices introduced radical changes, such as Amazon Alexa. Alexa combined the voice control, natural language processing, and artificial intelligence with IoT technology. IoT became an enabler of the advanced technology. The integration of all the technologies created a bigger outcome than they operating independently. Customers are more willing to pay for such great innovation because the value it creates is very obvious. Therefore, IoT products need to find the optimized value versus price balance to enhance the IoT adoption. Let's look a little deeper at common IoT security issues. Security is a huge issue in terms of IoT because when deploying billions of devices worldwide, which has already been done, and with more coming online by the second, the attack vectors for hackers expands dramatically. The challenge of securing the IoT is compounded because most companies bringing IoT devices into the market are operating under the misguided assumption that their devices aren't vulnerable. They assume their devices are safe and therefore secure. The same false assumption is held by most of their customers. They're deploying IoT devices assuming that the devices are secure and wonder who would want to bother with hacking into a doorbell or a pressure monitor anyway. And yet we have many security breach reports showing the opposite to be true. The data shows most IoT devices aren't secure. It's critical to understand that a Jeep was hacked through the onboard diagnostics, or that a casino was hacked via the thermometer in an aquarium in the casino's lobby, or that a university's systems were hacked via a smart vending machine. It is essential to realize that any weak point can be attacked by hackers and other bad actors. Unsecured IoT devices provide very weak points to attack. Security weak points can be found in a variety of different areas, including network and the protocol translation points, and wherever there's multiple channel data flows. The ability to secure smaller devices may not be as robust as what you would normally expect with an enterprise security plan. There are areas where the data gets exposed during pre-processing or in other points of the evolution of the life cycle of that data. And then there are elements of exposure that are fundamentally rooted into a device identity and the trusted nature of that device. The idea of coupling IoT with blockchain conceptually has some merit. With the exponential growth of IoT permeating every aspect of our daily life, concerns have naturally arisen about not only how these devices will be managed, but also the data these devices produce. Blockchain, on the other hand, as a tamper-proof ledger with real-time access to transaction records, offers promise to IoT in fundamental ways. Integration of these two technologies seems like a natural fit. The marriage of IoT and blockchain yields a tamper-proof record of IoT device activities that is auditable in real time. Blockchain presents a paradigm shift for IoT. Blockchain offers a move from the centralized model for IoT to a decentralized model. Currently, the IoT infrastructure depends upon centralized data management and communication mechanisms. For instance, a smart home with multiple smart devices from various manufacturers experience problems such as the lack of multi-vendor interoperability and personal identifiable data being stored and managed by numerous centralized entities that require trust. The method in which the IoT devices communicate with one another is passed down from the legacy client-server model. This client-server model requires an edge device or sensor to discover, authenticate, and communicate through cloud infrastructure that possesses enough computing power to process these requirements. While this method has worked for legacy computing needs, the growing wave of connected devices pressures the economics and securities of the centralized model, resulting in a single point of attack enticing for hackers. Blockchain offers a distributed network and peer-to-peer communication model that can securely process billions of transactions without all of the infrastructure costs and risks associated with the centralized IoT model. As a result, a blockchain-based system for IoT not only reduces significant infrastructure costs, but also eliminates the single points of attack present in the current model.